Okay, we're doing our last types of quadrilaterals. So in this video, we're talking about trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So that means I have one and only one pair of parallel sides. So when we're doing a coordinate plane problem like this, we still are going to do all four sides, the slopes of all four sides. But I'm going to show that these two are the same and then these two are different. So let's go ahead and do that. So the slope of HK, if I count that out, that's up 1, 2 over 1, 2, 3, 4, which reduces to 1/2. And then the slope of IJ, that's going to be up 1, 2, 3 over 1, 2, 3, 4, 5, 6, which reduces to 1/2. So we have one pair of parallel sides, but now we need to show that the other ones are not. Otherwise, we'd have a parallelogram. So I'm going to do HI next. So HI, this is going down 1, 2, 3, 4, 5, 6 over 1, 2, 3. So that's -2. And then we're going to have KJ. That's going down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. So that's -1. So these are just as important as the ones that are the same. All right, so that shows that that is a trapezoid. Now we also have isosceles trapezoids, and those are going to be just like an isosceles triangle where two sides are the same. An isosceles trapezoid has their two legs the same. All right, so we call these the bases. That's a base, that's a base, but these would be the legs. So the legs are congruent in an isosceles trapezoid. So if a trapezoid is isosceles, then the other thing we know is that each pair of base angles is congruent. All right, so I know that D and C are going to be congruent, and then A and B are also going to be congruent. Now they won't necessarily be congruent to each other, all right, but keep in mind too that these are consecutive interior angles, so these will add up to be 180 as well, this one and this one. All right, so also if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if you just know one set, that's kind of like the converse, then you know it's isosceles trapezoid. All right, so a trapezoid is isosceles if and only if its diagonals are congruent. And let's think about this for a minute. If I trace out a diagonal that makes that triangle, so in this triangle, I know this is congruent, and I know this angle is going to be the same as this angle. All right, so if I do the other diagonal, notice that I have that side the same and that angle the same, and then they have this reflexive side that they share. So those triangles are congruent by SAS, and that would mean that those diagonals have to be congruent. So that's why we know that isosceles trapezoids have congruent diagonals. All right, so let's do a little bit of application of this. So we have WXYZ as an isosceles trapezoid, so keep in mind we know base angles as well. Okay, so I know that the measure of angle X is 110, and then I also know that these are going to be supplementary, so this has to be 70 and 70. All right, and then we also have over here, this is an isosceles trapezoid, and all they did was give us this angle. So I know this angle will also be 35. And then I know that these are going to add up to be 180. So these are going to be 145 apiece, here and here. All right, we also can do a mid-segment for a trapezoid. So mid-segment is very similar to what we did with the mid-segment of a triangle. It connects the midpoints of each of the sides of the legs of the trapezoid, all right, and it's parallel to those bases, right? And then the length of it is going to be 1/2 the sum of those two. So MN is going to be 1/2 BC plus AD. Okay, so how do we use that? So for example, if I knew that I had this trapezoid with these bases, I would know AB is the mid, if we know that AB is a mid-segment, so they would really need to tell us more information. So they would have to do something like that, or tell us in the directions. But we know that that's parallel, and then I could find AB by doing 1/2 8 plus 10. So that'll be 1/2 of 18, which is 9. So AB equals 9. Okay, so we've got lots of things going on with trapezoids. We've got isosceles, base angles, and mid-segments. Then we have a kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides. So looking at this diagram right here, consecutive congruent sides, these are the ones that are right next to each other. All right, the opposite sides are not congruent. Okay, so these have to be something different. All right, so if a quadrilateral is a kite, then what we know is that the diagonals are perpendicular, right here. And let's think about this for a minute. In a kite, I know that, and if you think about this, this is symmetrical. So this diagonal right here is the only one that's cut in half. Notice that this one, the green one, that is not cut in half. That is not bisected. And this is not a parallelogram, so that's okay. But I'm just pointing that out to you, that the green one is not bisected, but the red one is. So if I know that, then I know that, well, I know lots of things, but I know that these are going to be congruent triangles, and then I'm going to have those right angles. Okay, so we know that those are perpendicular. We also know that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, and that's going to be where those two non-congruent sides meet, all right, along that axis. So think about the symmetry of a kite. I think that will help you the most. And think about, okay, well, I could fold this along that green diagonal, and everything would match up. All right, so let's use that to our advantage. So we're given two of the angles in a kite, and we would know that these are going to be congruent to each other. Again, this is symmetrical if I were to fold that. So I know, you could just call those x. So I have 2x plus 37 plus 73. Those all have to add up to be 360. So I'm just going to subtract those from 360 and then divide by 2. So when I subtracted them, I got 250, and then when you divide by 2, you get 125. So each of those are 125 degrees. And then we could do the same thing here. Right, we're going to subtract those two angles that were already given from 360, and then the remainder is going to be split equally amongst those two angles. So I'm left with 124. So now I'm going to divide by 2 to get what each of those is. So each of these is 62 degrees. So if you wanted to pause this part of the video so you could fill in your hierarchy, just these are all of the things we know about all these shapes. That might be helpful. You can pause it at any time, and then I'll scroll down just a little bit more so you can see everything down here. All right, so then we'll start reviewing after we master this section.